What up? Is this the part where I'm like, what up, YouTube? No? Alright, check this out. Calculating any rake wall can be super easy if you can figure out the keystroke sequences that are required on a scientific calculator to find all the trigonometric functions that you'll need to calculate the components of this wall. The first thing I do when I'm drafting and calculating a rake wall is I identify the pitch. We're going to say this one's a 712. That can usually be found on the blueprint. Most of the time it's expressed with a backslash. Some architects will draw it like that. Some will use a semicolon. Some will get creative and just do it in a way that you've never seen before. But generally, I see it drawn with a backslash. And all that backslash means is divided by rise divided by run. There's two formulas that I need to figure out this whole entire rake wall. The first one is the rise-run ratio, and the second one is called the secant. To find the rise-run ratio, you hit 7 divided by 12 on a scientific calculator. The number that's displayed is a decimal. For a 712, it's 0.5833. That's the rise-run ratio. To take all this a step further and find the secant, with 0.5833 displayed in the calculator, the rest of the keystroke sequence is inverse, tangent, cosine, 1x equals. The number displayed in the calculator is the secant. And for a 712, it's going to be 1.1577. That's the secant. That's what I need to figure out any rake wall. I need the rise-run ratio and I need the secant. The next thing I need to figure out is what the short point of stud number 1 is going to be. We'll call this stud 1. We'll call this stud 2, stud 3, stud 4, stud 5. Let's just say this is a truss that's sitting on a standard height wall and the studs are 104 and 5/8. The truss sits on top of that standard wall and begins its vault right there and takes off up at a 712 pitch. That's the example that we're going to use in this scenario. So to figure out the short point of stud number 1, I take the standard stud, 104 and 5/8, plus an 1.5 plate, plus another 1.5 plate, because we have a very top plate on there. And that's going to equal 107 and 5/8. To get down to that short point right there, I need to minus these 2 rake wall plates out of there. Now I'm using an 1.5 and an 1.5, so that's 3 inches. But when that plate is turned at a 712, it doesn't measure 3 inches anymore when it's measured plumb. We call that the plumb dimension. To calculate the plumb dimension, I take the actual thickness of the material. So in this case, it's 1.5 plus 1.5, so it's 3 inches. I take the actual width of the material, 3, times the secant, times secant. That's going to equal the plumb dimension. So we'll put plumb dimension. 3 times the secant is 3.4751. We're not going to worry about converting that decimal into a fraction right now. But that equals a 1/2 inch. So the plumb dimension of 2 plates on top of a 7/12 rake wall is 3.5 inches. So to get the short point of stud 1, I'm 104 5/8. It's my standard stud. Plus 1.5 inches, plus 1.5 inches, minus the plumb dimension. So minus 3.5. If you run through that whole entire sequence in your calculator, you're going to get a number in your display of 104.125. That's 104 1/8. So usually when I'm drafting this stuff out on paper and I figured out the short point of stud number 1, I'll just write it down somewhere. 104 1/8. And if I need to write the decimal, I give myself that too. So 104.125. This is like the golden dimension. Once you have that figured out, short point, you can find all the other studs very easily. So let's go stud 1, stud 2, stud 3, 4, and 5. First thing I need to know is how long my bottom plate is for the wall. You can grab that off a blueprint, usually, with a little bit of basic math. We're going to say that this one's 60 inches. So I need to know that. To find the long point of stud number 2, I calculate everything to the long point. I need to know the distance measured horizontally along the bottom plate from the short point edge of stud number 1 to the long point edge of stud number 2. If you're doing a 16-inch on center layout, most likely this dimension is going to be 16 3/4. Most of you watching this will probably know the reasoning for that. This can be whatever you want it to be, however you lay out your studs. For me, it's going to come out at 16 3/4. That's the run. To find the long point of stud number 2, I take 16 3/4 times the rise-run ratio for this pitch. So 16 3/4 times 0.5833 equals 9.7703. Don't worry about converting that to a fraction. What this represents is, if you were to draw from the short point of 1, horizontally level, straight across to the long point edge and back up. See, that creates a triangle right there. From here, that's the short point of number 1, straight up to the short point of number 2, is 9.7703 inches taller than the short point edge of stud number 1. So to finish this out, to find the long point of 2, I take 9.7703, add that to my short point of 104 1/8. That gives me a stud number 2 of 113.8952. Again, don't worry about converting that to 16ths. We'll do all that at the end. Now to find stud number 3, you could do it the same way. You'd be 16 3/4, and then the long point edge of 3 is most likely 16 inches away from the long point edge of 2. So you could go 16 3/4 plus 16 equals, and that would be your effective run. And then you'd take that effective run times the rise-run ratio, and that would give you another number. But we're going to do it a little simpler way. If this was like a big rake wall and there was more than 5 studs, there was 10 or 12, it's easier once you find the long point edge of 2 to apply what we call a 16-inch on center step to every successive stud that follows. What that means is that we know that these edges are exactly 16 inches away from each other. So each stud is going to grow the same exact amount every single time. That's called the step. So to calculate the step, the amount that each stud grows when it's exactly 16 inches from each other, you take 16, that's your run, times the rise-run ratio, 0.5833 equals. So for a 712, the 16-inch on center step is 9.3328. Don't worry about converting the decimal. So I'm just going to go 16 OC equals 9.3328. To find long point stud number 3, I take 113.8952 plus the 16-inch on center step of 9.3328. That gives me a long point of 123.2280. I add the step to that again. That gives me the long point of 4. That's going to be 132.5608. Now I can't use the 16-inch on center step. It doesn't apply to number 5 because number 5's long point edge is most likely not 16 inches away from stud number 4's long point edge. So that's easy too. Stud number 5's long point edge is 60 inches away from stud number 1's short point edge. That's my effective run. I take 60 times the rise-run ratio for that pitch equals 34.998. If we continued this level across, 34.998. That's this. That's how much higher number 5's long point is from stud number 1's short point. You can see it's just another triangle again. So I add 34.998 to 104 1/8. That gives me a stud number 5 long point of 139.123. Now the last stud that I'm missing is number 1's long point. I have the short point already, but if I'm giving this list to a guy to cut, I want everything in long point form so there's no confusion. So to convert that to a long point, stud number 1's long point edge is 1.5 inches from stud number 1's short point edge. That's my effective run. So I take 1.5 times the rise-run ratio. That's 0.8749. That gives me 104.999. Again, not going to worry about converting those until right now. To convert all that into 16ths, it's super easy and most of you already probably know how to do it. You take 0.9999 times 16. 0.9999 times 16 is going to be 15.9 16ths. Because this first number behind the decimal is 0.5 or higher, we round 15 up to the next 16th. So that'd be 16/16, which is 1 inch. So this becomes 105. 0.8952 times 16 is 3.6/16. Because that's 0.5 or higher, we round that up to the next 16th. That becomes 4/16, which is a quarter. 113 and a quarter. 0.2280 times 16 is 8.9/16. Again, it's 0.5 or higher, gets rounded up to 9/16. 0.5608 times 16 is 9/16. After you do this for a while, you start to memorize what some of these decimals are and how they convert into 16ths. So it definitely gets a lot easier over time. 0.123 times 16 is 1.9/16. Because it's 0.5 or higher, it gets converted to the next 16th, 2/16. That's a 1/8 of an inch. 139 and 1/8. All right, so we got the cut list done for all the studs. If all the studs were cut square to the long point of those numbers and labeled accordingly, everything's going to fit in there nice and perfect. Last couple things we need are the top plate length and the very top plate length, which in this situation, they're both exactly the same. To find the top plate length, I take my bottom plate, which is 60, that's my effective run, times secant, which is 1.1577. So effective run times secant, and that's going to give me 69.462. You can convert that to a decimal. 0.462 times 16 is 7/16. 69 and 7/16. And that's going to be long to short. So it's the long point to the short point. Okay? The very last thing we need is the layout. So we can lay out the top plate so we know exactly where the long points of these studs go. To find the layout from the short point of that top plate to the long point of stud number 2, we're using the secant again. Down here horizontally along the bottom plate, it's 16 3/4 of an inch. Short point of 1 to long point of 2. That's my effective run. 16 3/4 times the secant equals 19 3/8. That's from the short point to the long point. Now, how we calculated a step for the amount of vertical growth of each stud that was exactly 16 inches from each other, we can do the same thing for the layout mark. So 16 but instead of times the rise run ratio, we're times the secant. That's going to equal 18.5 for this 712. That could also be expressed as on center. So the rest of these studs from the long point of 2 is exactly 18.5 inches on center all the way up. When I'm laying that out, I put my 0 end of my tape there, mark 18.5. Then I put the 0 end of my tape, mark 18.5. I keep moving my tape every time. I try not to do the math in my head because it'll get me screwed up. And then obviously the long point of stud number 5, don't need a layout mark for it since it sits flush on the edge of the top plate. You can apply these principles in a lot of different ways. This is just one simple wall. And this stuff, if you can build the muscle memory for it, makes things super easy and everything will fit together perfectly in the field.